So today we'll be again discussing some important concept of your aldehydes and ketones. So in that specifically we are going with methods of preparation of aldehydes. So aldehydes can be predominantly prepared from various methods. One among them is Rosenmund's reduction reaction. This is one important method. Second, we can prepare it from Stephen's reduction reaction. Third, we can prepare it from Gattermann-Koch reaction. Fourth, we can prepare it from Itard's oxidation reaction. Fifth, we can prepare it from by side chain chlorination method. The sixth one you can prepare it from by using CrO3, that is chromic oxide. So these are the various six methods of preparation of aldehydes specifically in concerned way. So let us go with the discussion for one by one. First we are taking Rosenmund's reduction reaction. So in Rosenmund's reduction reaction, what will happen? So which is going to be a very important question for your board examination. So here we are going to take acyl chloride. Acyl chlorides are RC double bond OCl. Acyl chlorides are also called as acid chloride. So this acyl chloride is hydrogenated over palladium and barium sulfate. So you are going to get aldehyde. So one among the H and Cl will eliminate as HCl. You are going to get RC double bond OCl converted into RC double bond OH. This is called aldehydes. So this is going to be your general reaction for the Rosenmund's reduction reaction. So if you create an example for this, you can take an example of a benzoyl chloride. Not benzyl chloride, it is benzoyl chloride. Benzene with C double bond OCl. So I will write a name over here. This is called benzoyl chloride. So as usually you treat with hydrogen, hydrogenated over palladium and barium sulfate. So you know what will happen? One of the hydrogen and Cl will eliminate in the form of HCl. So if HCl goes, then you will be getting benzene with C double bond OH. So this compound we call it as benzaldehyde. So this is going to be one of the predominant reaction where you can cover up 2-mark question. So moving on to our next reaction, that is Stephen's reduction reaction. So here what will happen? Cyanides or nitriles are reduced. So when you take up an example for this reaction is, or GR you can take. So to write a general reaction, I take cyanides. I'm extremely sorry. We take cyanides or nitriles. Carbon nitrogen triple bond compounds are called as nitriles. It is reduced by using stannous chloride in presence of HCl. That is HNCl to HCl. You have to convert the triple bond into double bond. Add one hydrogen on either side, and you will be getting RCH double bond NH. So this RCH double bond NH, these compounds are also called as imines. So when these imines are hydrolyzed by using H3O+, you get converted into RCHO, that is nothing but RC double bond OH. So these compounds are also called aldehydes. So if you want to create an example for this, so you can take ethane nitrile or methyl cyanide. Then when you are using SnCl2 and HCl, stiffens reducing agent, then you will be getting CH3, CH double bond NH. So this is as usual, the compounds are called imides, which upon hydrolysis with H3O plus, you will be getting CH3, C double bond OH. So this compound we call it as ethanol. So when you enter stiffens reduction reagent or reaction, there is one important point to be noted down, which is going to be very, very important over here, is that suppose if I take a compound containing different multiple bonds like double bond and a triple bond. So you can notice over here, specifically this example you need to concentrate more. If you go for site of reduction, we have a two site of reduction. One is this double bond, which can become a single bond. Another one is a triple bond, which can become a double bond. So what your SnCl to HCl will do, it will reduce both the double bond as well as a triple bond. It is not selective. It will never select a triple bond or a double bond. It will reduce everything. So if it is going to be reduced, then you are going to get CH3, CH2, single bond CH2. See, double bond has become single bond. And the triple bond obviously will become double bond NH. So this is when hydrolyzed with H3O plus. Then your product will be CH3, CH2, CH2, C double bond H. Means, have you observed, if you are using SnCl to HCl, your double bond also reduced and even triple bond also reduced. Means your SnCl to HCl, which is there as a stiffens reducing agent, is going to be non-selective reagent, because it doesn't select a triple bond or a double bond. It will reduce everything. That's why it is called as non-selective reagent. The non-selective reagent is stiffens reagent. Suppose if you take the same material and you don't want to reduce a double bond, and you want to reduce only triple bond selectively, means you want to keep this area as it is and only triple bond should be reduced, then here you have to use dibal H. Dibal H is also called diisobutyl aluminum hydride. So then what will happen? You will get on to final product, that is CH3, CH double bond CH, C double bond H. Means, have you noticed, only triple bond has been converted into aldehyde group. Means only nitriles are reduced, only this part of the molecule is being converted into aldehydes. Means left side everything remains the same. Therefore, where dibal H is there, this dibal H will straight away becomes selective reagent. Therefore, if you consider, very simple here, which is a selective reduction reagent used for the reduction of nitriles, means that is diisobutyl aluminum hydride. So this is commonly called dibal H, is going to be straight away selective reducing agent for the reduction of nitriles or cyanides. That's all about your second reaction, which is said to be Stephen's reaction. Then we move on to the third reaction, that is Gattermann-Koch reaction. This is going to be very simple and easiest one. Just give me a minute of time. Also, I'm going to make it up. Third one. Gattermann-Koch reaction, which is again important, very important 2-mark question in fact of Karnataka board examination is concerned. So here what will happen? We directly take benzene, and this benzene is treated with carbon monoxide and HCl in presence of anhydrous Cl, Cl3 or CuCl, carbon monoxide and the CH will be added to benzene, thereby giving benzene as it is C double bond OH. This is itself the reaction. This is called benzaldehyde. So conversion of this benzene to benzaldehyde is most favored by Gattermann-Koch reaction. We are moving on to the next reaction, that is third one is over now. The fourth one is all the way about Itard's reaction. This is one of the most complicated and toughest reaction in fact you can consider. So here what will happen is, so we take toluene. Toluene is benzene with CH3. This benzene with CH3 is treated with chromyl chloride. Chromyl chloride is CrO2Cl2. In presence of carbon disulfide, we get on to this molecule CH3, oxidation, removal of hydrogen will become CH. This entire CrO2Cl2 is there, na? It will be added in the box, that is OCRO, 2 hydrogen you remove, that will come out in the middle. HCl, to balance the hydrogen we are multiplying by 2. So this complex is important for us. This is called chromium complex. So when this chromium complex is hydrolyzed with H3O plus, this entire group is going to be removed. In place of this we are going to add oxygen. Oxidation reaction, na? That's why CH will become CHO. So benzene with CHO is also called as benzaldehyde. So that's all about Itard's reaction. We are moving on to the next reaction now. By side chain chlorination of toluene. So reaction number 5 we are moving on, students. By side chain chlorination followed by hydrolysis. This is also going to be one of the most important reaction in concern with. So here what will happen, same toluene we take, benzene with CH3. This is chlorinated by using H mu in presence of light. So as usual, out of CH3 2 hydrogen will be replaced by 2 chlorine. You'll be getting benzene with CHCl2. This is called benzyl chloride. This is toluene. So keep practicing this reaction, students. So going to be most important, and you are hydrolyzing by using H2O. So CHCl2 at the end is going to convert into CHO. This is called benzaldehyde. So this is all about the fifth reaction, that is side chain chlorination followed by hydrolysis. And the last under the preparation of aldehyde to end the video, that is by using chromic oxide. That is obviously another important 2-mark question, which is seems to be most difficult one, sixth one. By using chromic oxide CrO3. So same we are taking toluene, using chromic oxide and acetic anhydride, that is CH3CO twice O, somewhere around 273 to 83 Kelvin the reaction will work. So then you are going to get benzene. As usual, CH3 will become CH. You read from here, O, COCH3 going to become twice. This is called benzalidene diacetate. This complex, when we hydrolyze by using H3O plus, we are going to get benzene with CHO, nothing but benzaldehyde. So this was all about, students, a 6 method of preparation of aldehydes. So I hope the video has been helpful to you. So Rosenmann's reduction reaction, Stephen's reaction, Gutterman reaction, Itard's reaction, side chain chlorination, and by using chromic oxide. So in Stephen's reaction, the selective reagent used is dibal H, the most important content to be remembered. So I think the video was helpful. Thank you very much, everyone. Let us meet back in the next video about the preparation of ketones.